This is Algebra 2, Unit 11, Lesson 9, the rest of the notes on sinusoidal modeling. Okay, so we left off on exercise 3 on sinusoidal modeling from the Ed puzzle from previously. So let's work this out. A Ferris wheel is constructed such that a person gets on the wheel at its lowest point, 5 feet above the ground, and reaches its highest point at 130 feet above the ground. The amount of time it takes to complete one full rotation is equal to 8 minutes. A person's vertical position y can be modeled as a function of time in minutes since they boarded t by the equation y equals a cosine bt plus c. Sketch a graph of a person's vertical position for one cycle and then determine the values of a, b, and c and show the work needed to arrive at your answers. Okay, so that's what we're going to do. We need to figure out what a, b, and c are for the equation y equals a cosine bt plus c. All right, so the first thing that we need to do is to look at what we know about the points. All right, so we know that our lowest point is at 5 feet, so y min is 5. And highest point would be 130, so 5 is the y min, and this is going to be y max. Is going to be 130. Okay, so we know that it's going to start down at 5 and it's going to go up to 130 and then it's going to come down. So that's a cosine function. All right, so that means that it's going to be actually an inverted cosine function, so that should tell us something as well. Okay, so if we work this out, the amount of time it takes to complete one full rotation is equal to 8 minutes. Well, isn't that one full rotation is the period? So P is going to be 8. All right, so now that we have that, we can figure out our amplitude, our midline, and our frequency. All right, so let's figure out our midline first of all. All right, so if this is 5 and this is 130, if we want to figure out what C is, it's going to be the halfway between that, right? So if we take the average of those two values, divided by 2 is 135, divided by 2 is 67.5. Okay, so C is going to be 67.5. Okay, now the amplitude. All right, so if we do the amplitude, let me put this right on the graph so we're doing it here. Okay. All right, so when I draw this on my graph, my midline is going to be at 67.5. I'll put that maybe right here. All right, so this is going to be at 67.5. All right, my minimum is at 5. My maximum is at 130. So there's my graph, so what I have. All right, now, so I know my midline is there. All right, now my amplitude is going to be the distance from, if this is going to be 67.5, it's going to be the distance from either the midline to the max or the minimum. So if I take, for example, the midline, A is going to be 130 minus 67.5. All right, and that's going to give me 62.5. Let me make sure I'm right here. 130 minus 67.5 is 62.5, yes. All right, so that's going to give me 62.5 as my midline. Now, the other way that you can do this is to subtract them and divide by 2. So 130 minus 5 divided by 2 is this. It will still give you 125 divided by 2, which is 62.5. So you can do it that way as well. All right, so let me put this on my sketch. Whoops, hit the wrong one, sorry. All right, so that means that, well, with our amplitude though, however, this has got to be 62.5, but remember it's the absolute value. So since we're starting here and going here, what kind of 62.5 is going to be? Well, in this case, A is going to be negative 62.5 because notice this is inverted. Okay, Now, it's because it starts at the minimum instead of starting at the maximum. All right, now the last thing we need to figure out is the B. So we know what A is, we know what C is. B is going to be the frequency. All right, now it says the amount of time it takes to complete one rotation is equal to 8 minutes, which we said was the period. So the formula is B times P is equal to 2 pi. To figure out B, we need to know what P is. In this case, it's 8, so it's B times 8 is equal to 2 pi. Solve for B. 8b is equal to 2 pi, divide by 8, and b is equal to pi over 4. Okay, so let me put that on my sketch. This is going to be at 8, right there. That's my period. All right, so my equation is going to be y equals negative 62.5 cosine. B we just figured out is pi over 4 t instead of x. There we go. And then plus c, which we said was 67.5. All right, let me go back to my picture here and sketch this. All right, so here's what happens with cosine. All right, so we said that this is going to be 8. So that means if we divide this into 4 sections, 8 divided by 4 is going to be 2. So this is going to be 2, 4, 6, and 8. So what happens at each of these points? All right, well, we started at 5. Cosine goes to the midline. This would be the next point would be at 2. And then at 4, it would be at 130. 6, it would be back to the midline at 67.5, and then back at 8, it would be at 5. So your cosine graph would sketch to look like this. Pretend I can draw a nice curve. Okay, so each one of these values, we divided by the period by 4 so that we can see where each of those points are. So because we started at the minimum, it's actually negative. So we started at 5, went to the midline, up above, back to the midline, and then below. So there we go. That is figuring out A, B, and C and doing the sketch. All right, now let's do the last question. For exercise 4, the possible hours of daylight in a given day is a function of the day of the year. In Poughkeepsie, New York, the minimum hours of daylight occurring on the winter solstice is equal to 9 hours, and the maximum hours of daylight, including on the summer solstice, is equal to 15 hours. If the hours of daylight can be modeled using a sinusoidal equation, what is the equation's amplitude? Okay, now the amplitude, remember, is the height of the wave. So what's happening is the minimum is going to be at 9, and the max, y max, is going to be 15. So that means that the amplitude is going to be the distance between the midline when we do this. All right, so if we look at our graph, whatever it happens to be, say you started it in the winter time, you go winter is at 15, and then you go down to summer, which is 9. And it keeps going back and forth, right? So 15 to 9. All right, so what we need to know for the amplitude is how far is it between them? Well, we know 15 minus 9 is going to be, and divide that by 2, is 6 divided by 2 is going to be 3. So that means that the difference between these is going to be 6. So from here to here is going to be 3, and here to here is also going to be 3. So that means that the amplitude has got to be 3 when you do that. Okay, so that's it for sinusoidal modeling. You can get started on the homework.